In 2006, Pluto was generally viewed as a distant, frozen object sitting on the edge of our solar system. It was considered a leftover fragment from planetary formation, cold, inactive, and largely unimportant. That same year, its classification changed to a dwarf planet, sparking widespread debate and emotional reactions. Many people felt as if Pluto had lost its significance. Over time, it came to be seen as small, remote, and mostly forgotten. For years, scientists believed Pluto was a quiet and unchanging world. The assumption was that it had no real internal or surface activity. However, this perspective began to change as more advanced observations became available. New data from powerful telescopes started to challenge earlier ideas. Instead of being a simple frozen body, Pluto appeared far more complex and active than expected. One of the biggest surprises involved its atmosphere. Previously thought to be extremely thin and inactive, it is actually composed mainly of nitrogen, along with methane and carbon monoxide. New findings revealed layers of haze high above the surface, along with faint cloud-like formations. These features suggest that chemical processes are actively occurring. Different atmospheric layers behave differently, showing signs of motion and variation. This points to the possibility of weather-like patterns, even at such a great distance from the Sun. Pluto's surface has also revealed unexpected characteristics. It was once assumed to be ancient and unchanged, but some regions now appear relatively young. These areas may have formed through processes that scientists are still trying to understand. One theory involves cryovolcanism, where icy materials like water, ammonia, and methane erupt instead of molten rock. If this is correct, it would mean Pluto still has internal heat. This challenges the idea that small, distant worlds are completely inactive. There is also growing interest in what may exist beneath Pluto's surface. Some researchers suggest there could be a hidden ocean beneath its icy crust. While this does not indicate the presence of life, it raises important questions about chemistry in extreme environments. Organic compounds have also been detected, adding to the mystery and suggesting that complex chemical reactions may be possible. Pluto's largest moon, Charon, has also shown signs of an interesting past. It features massive canyons and unusual surface regions that hint at previous geological activity. The relationship between Pluto and Charon is unique, with both bodies strongly influencing each other through gravity. Together, they form a system unlike most others in the solar system. Another unusual aspect of Pluto is its orbit. It is more tilted and elongated compared to the planets. Scientists believe this may be the result of past gravitational interactions. Pluto also maintains a stable orbital relationship with Neptune, which helps keep its path consistent over long periods. Some areas of Pluto's surface show very few impact craters, suggesting that the landscape is being reshaped over time. Ice may slowly move and renew the surface, covering older features. There are also indications that internal heat, possibly from radioactive decay, may still be affecting the planet. Pluto's atmosphere behaves in interesting ways as it travels around the Sun. When it gets closer, surface ice turns into gas, forming an atmosphere. As it moves farther away, this atmosphere is expected to freeze again. However, it appears to last longer than scientists originally thought, hinting at hidden heat sources beneath the surface. Today, Pluto is no longer seen as a simple, frozen relic. Instead, it is recognized as a dynamic and evolving world full of mysteries. What once seemed lifeless now shows signs of activity and change. Its story is a reminder that even the most distant places in space can surprise us. As scientists continued studying Pluto, its complexity became even more apparent. Data from NASA's New Horizons mission provided the clearest look ever at this distant world. When it flew past Pluto in 2015, It revealed details that completely changed previous assumptions. Instead of a dark and featureless surface, Pluto displayed vast plains, towering ice mountains, and regions unlike anything seen before. One of the most striking features discovered was a massive, heart-shaped region known as Tombaugh Regio. This bright area is made largely of frozen nitrogen ice and appears to be relatively young. Within it lies a smooth plain called Sputnik Planitia, which shows almost no impact craters. This suggests the surface is constantly being renewed, possibly by slow movement of ice similar to glaciers on Earth. Scientists believe that convection may be occurring beneath this icy surface. Warmer material slowly rises while cooler material sinks, creating a gradual but continuous reshaping of the landscape. This process indicates that Pluto still retains internal heat, even after billions of years. Such activity was completely unexpected for a body of its size and distance. Further observations also revealed towering mountains made of water ice. These structures can reach heights of several kilometers and are strong enough to support their own weight, unlike softer ices like nitrogen or methane. Their presence suggests that Pluto's crust is more diverse and structured than previously believed. Another surprising discovery was the blue tint of Pluto's atmosphere. Sunlight interacting with haze particles creates this color, similar to the way Earth's sky appears blue. These haze layers extend far above the surface and change with altitude, showing that the atmosphere is more active and layered than once thought. Seasonal changes on Pluto are also more complex than expected. Because of its highly elliptical orbit, Pluto experiences extreme variations in temperature over time. As it moves closer to the Sun, ices sublimate into gas, thickening the atmosphere. When it moves farther away, those gases begin to freeze again. However, the transition is not immediate, suggesting that heat may be stored beneath the surface and released slowly. There is also growing evidence supporting the idea of a subsurface ocean. Some models suggest that a layer of liquid water could exist beneath Pluto's icy shell, kept from freezing by internal heat and possibly insulated by layers of ice above it. If true, this would place Pluto among other ocean-bearing worlds like Jupiter's moon Europa and Saturn's moon Enceladus. Pluto's interaction with its moon Charon also adds to its uniqueness. The two bodies are tidally locked, meaning they always show the same face to each other. This creates a kind of binary system, where both objects orbit a common center of mass located between them. Such a configuration is rare and provides valuable insight into how planetary systems can form and evolve. In addition to Charon, Pluto has several smaller moons that contribute to the system's complexity. Their unusual shapes and rotations suggest a history of collisions and gravitational interactions. These factors may have played a role in shaping Pluto's current structure and behavior. What makes Pluto truly fascinating is how it continues to challenge expectations. Each new discovery reveals something unexpected, forcing scientists to rethink earlier models of planetary evolution. It is no longer seen as a static remnant of the past, but as an active world that still holds many secrets. Pluto's story is a powerful reminder that exploration can transform our understanding. Even in the farthest reaches of the solar system, there are worlds that are dynamic, evolving, and full of surprises.